Hi everyone, welcome back to Bay of IT. Today's topic will be very unique and interesting as it is surely going to blow your mind. We are going to discuss about a very specific component of a machine, and that component is so critical that it defines the state of a machine if that machine is considered to be dead or alive. And this specific component considered as a soul of machine as well. So you can guess the importance of this specific component which we are going to learn today. What exactly this component is, why it is so much important, and what exactly sort of operations in the back end it performs, that we consider this particular component as a soul of machine. So let's begin with a very specific and small example. Consider you are having computer. It means that you are having hardware and an operating system. Now consider I have to directly interact with a hardware using that operating system. Will that operating system allow me to directly communicate with the hardware? The answer is no only. Reason: we all know the properties, the behavior, and the functions of an operating system.
It only sets the platforms, it provides the interface, but it does not allow you to directly interact with the hardware.
But what about device drivers?
I partially agree with this statement. Reason I will explain in the mid of this particular lecture, and you will come to know why actually I partially agree with this statement. Now, the question is, if not the operating system, not the device driver, then how come the hardware directly understands what exactly user is commanding? So there is a specific component available on each and every hardware's electronic circuit, and that component is responsible to interact with the hardware. And this particular component only allows your device driver to communicate to the hardware. So what exactly that component is? That component we called as a firmware. So today we are going to learn and understand about the firmware only. What exactly this firmware is, why it is so much important, why we call this firmware as a soul of machine, and what sort of back-end operation does this firmware execute. Now, what exactly is the firmware? Firmware is nothing but a program or a software which is hard-coded on a specific hardware component, or you can say embedded on a specific hardware component. Now the question raises, why exactly we requires to embed or hard code specific code or a program on a hardware component? Instead, we could have easily executed that particular code onto an application layer. Now to get the answer of this question, we first have to understand two important things of any hardware device, that is, a backend operation and the workflow of an electronic circuit, which is available into that specific hardware. Now, why exactly I use electronic circuit term? The reason: we are going to interact with the hardware, and each hardware within the electronic system will have an electronic circuit within it. And that electronic circuit will help the hardware to execute its operations. Now, if I say electronic circuit is there, then there will be a specific component on that electronic circuit will be present. Either it will be a microprocessor or a microcontroller or both of them. Depends which exactly machine you are having. I will give the key and very important a single difference between these two components, and you will come to understand why exactly these two components are different. 1. Microprocessor. Microprocessor contains only CPU in it, and it is completely dependent on external memory, external storage, and external I/O devices. On other side, if I say microcontroller, it contains entire thing. We call it as a mini computer. It will have its own processor, memory, storage, I/O devices, and own firmware as well. Now, come to the example side. Consider you are having keyboard attached to your computer. And if you see the structure of a keyboard, inside that there will be an electronic circuit, and that electronic circuit will be surrounded by certain cables and wires. And there will be one microcontroller on that particular circuit as well. So once you provide the power to that keyboard, the microcontroller starts sending electronic signals into the entire circuit area using those cables, and it starts creating one electronic loop. Now, for an example, if you want to press alphabet A on your keyboard, once you press alphabet A, that entire loop which has been created by providing the power, that loop will be closed. And then the microcontroller which is on the keyboard side will be alert. And it will capture the exact location of alphabet A, and that location will be provided to its own firmware. Now, what exactly the firmware will do? It will decode that exact location address into its hexacode. For example, that hexacode is 040X. Now this hexacode will be packed into as a data package, and then after it will send towards motherboard. Now the motherboard microcontroller will receive that particular signal, and that signal will be provided to, again, its own firmware on the motherboard. Now this firmware will read that entire package, what exactly in it. It decodes that particular code which has been received from the keyboard microcontroller, again, pack it, and then after it initiates one interrupt request towards the CPU, that we have received certain signal from keyboard, and once that CPU stops whatever it is executing, then this microcontroller places the data onto the memory-mapped I/O register, which is a physical address of a bus line available on the motherboard. Now, what exactly CPU will do? CPU has already received the interrupt signal from the microcontroller. Now, it will switch the context to the piece of code inside the operating system kernel known as interrupt service routine. And this routine is a part of the keyboard driver only. Here, CPU will use its own internal registers to perform an I/O read instructions. And this instruction will tell the CPU, go to that particular hardware of the keyboard controller and copy the value sitting in that particular register into one of my own CPU registers. Now, here comes your device driver. Device driver will collect that value which is into the CPU register, and it will save this particular value into the memory, which is your RAM. Now, here comes the exact magic. Once the value has been stored into the RAM, the device driver itself having certain lookup table where each value has its own decode. For an example, we have considered the value as 040X, so it will be decoded into the device driver as the A alphabet or A key on the keyboard. Now, this device driver does not know which application is active, so it will hand this particular information to the OS input subsystem. That is, in Windows input stack, or can say in Linux, it will be evdev. The operating system will check which window currently has focus, example your browser, and then after this operating system will send a message to that specific application. That user has pressed A alphabet or A key on the keyboard. The application will receive that particular message from the operating system, and then after it will update onto your screen and shows the letter A.
This is all the process what exactly happened at the back end, whenever user gives any command or input to the machine. So this is all about the firmware.
We've learned what exactly firmware is, why we call it the soul of a machine, why it is present in every machine, what sort of functions it performs, and what are the back-end operations and workflows it follows and executes. If you have any query related to this topic, or would like me to cover any new topic in upcoming lectures, please note it down in the comment section. Also, do share this lecture with your friends and colleagues, and don't forget to like and subscribe.